Hi guys, and welcome to another video. Today we're going to be looking at Venn diagrams, and the first question we're going to be looking at is from the November 2010 paper 3. So what is a Venn diagram? Venn diagram is a graphical way of representing sample space and its events. Why do we use Venn diagrams? Well, we use Venn diagrams to solve probability problems. So let's read the question. It says, a school organized a camp for their 103 grade 12 learners. So 103 would be our sample space. The learners were asked to indicate their food preferences for the camp. They had to choose from chicken, vegetables, and fish. So the events would be chicken, vegetable, and fish. So in this case, we would let chicken equals to C, vegetables equals to V, and fish equals to F for our events. Following information was collected. 2 learners do not eat chicken. 5 learners eat only vegetables. 2 learners eat only chicken. 21 learners do not eat fish. 3 learners eat fish only. 66 learners eat chicken and fish. 75 learners eat vegetables and fish. Let the number of learners who eat chicken, vegetables, and fish be X. Now that's a very, very important statement that's given to us. So therefore, chicken and vegetables and fish will equals to X. So the intersection of all 3 events will be X. Draw an appropriate Venn diagram to represent the information and calculate X. So let us construct this Venn diagram. So for 1.1, our Venn diagram would look something like this. At the intersection of all 3 events is going to be equals to X. So we said we're going to let C equals to chicken, V equals to vegetables, and F equals to fish. So we got C for chicken, that's the event, F for fish, and V for vegetables. So now let's go fill in all our information. So it says here that 2 learners do not eat chicken, fish, or vegetables. So therefore, 2 learners would lie outside of these events. Let's fill in our sample space at the same time. Sample space is 103. So we represent our sample space on the top of our Venn diagram. 5 learners eat only vegetables. So for 5 learners eating only vegetables, we would now put 5 there. 2 learners only eat chicken. So 2 learners only eat chicken, so we represent 2. 21 learners do not eat fish. 21 learners do not eat fish. So therefore, we're going to say 21 minus 2 minus 5 minus 2. First 2 learners eat chicken only. 5 learners eat vegetables only. 2 learners do not eat chicken, fish, or vegetables. So 21 minus 2 minus 5 minus 2 will equals to 12. So therefore, we will have 12 learners who are going to eat chicken and vegetables. The next question, 3 learners eat only fish. Therefore, we put 3 learners there. 66 learners eat chicken and fish. So if 66 learners eat chicken and fish, remember that the chicken and fish is basically, there's chicken and fish there. Okay, so if 66 eat chicken and fish, therefore it's going to be 66 minus X. Alright, so 66 minus X. So here we would now put 66 minus X. Here. 66 minus X. 75 learners eat vegetables and fish. Now where is vegetables and fish? So vegetables and fish is here. So this whole portion of the Venn diagram is vegetables and fish. And again they tell us that 75 learners eat vegetables and fish. So therefore here we're going to have 75 minus X. So that's 75 minus X. Okay, so that's our completed Venn diagram. Now we can calculate the value of X. So for 1.2, in order to calculate the value of x, we need to say our sample space, which is 103, is going to equal to the sum of everything that's inside our sample space. And we're going to solve for x. So it'll be 2 plus 66 minus x plus 3 plus 12 plus x plus 75 minus x plus 5. And now don't forget the 2 on the outside of the events. It's included because it's in our sample space. So you always include that particular value as well. So we now solve for x. Remember that negative x and positive x cancels off, it's equal to 0. So we're going to be left with minus x. We're going to add up all these values. So we got 2 plus 66 plus 3 plus 12 plus 75 plus 5 plus 2. And that's equal to 165. Therefore, solving for x, x will equals to 165 minus 103, which is equal to 62. So x is equal to 62. So you can resolve the Venn diagram at this time. You can, wherever you got x, you can substitute it and you can now solve. But it is not necessary at this stage. So remember that when you're going to be asked probability type questions, you need to basically resolve your Venn diagram. So let's go and answer the rest of the questions. In 1.3, it says calculate the probability that a learner chosen at random eats only chicken and fish and no vegetables. When we calculating probability, remember that in this particular example, in Venn diagrams, we are going to look at the number of possible outcomes for that event to occur over the total number of outcomes in our sample space, which is going to be 103. So therefore, eats only chicken and fish, no vegetables. Chicken and fish and no vegetables is going to be 66 minus x. And we just calculated x to be 62. So 66 minus x is going to be 66 minus 62, which is 4. It'll be as follows. So we'll write only chicken and fish is going to equal to 4 over 103. Remember, once again, 66 minus 62 is going to equals to 4 and divided by your sample space. So 4 over 103. 1.3.2 eat only or any two of the given food choices, chicken, fish, and vegetables. So only two of the food choices, chicken, vegetables, and fish. So any two. So any two will be 12 there, which is also 4. So that's chicken and fish, and 75 minus 64. And also we can include any two will also mean eating all 3. So therefore, it's going to be as follows. The probability of any two is going to equal to, remember that we're going to divide it by our sample space, which is 103. So this will be 12 plus any 2, so that's 2. Remember, chicken and vegetables is 2. 66 minus 62 is 4, so we need to include that as well. So we can say 12 plus 4 plus 75 minus 64. So 75 minus 64 is going to be 13. Okay, and we can also include x, which is all 3, which will now be 62. So once again, in this particular problem, we can have 12 plus 4 plus 13, which is now going to give us 29 over 103, or you can add the 62, which will give us 91 over 103. So we can have two possible solutions for this question. If it's only 2, it will be 29 over 103, and so this is optional there. And if it's any 2, which means that all 3 is also included, it will be 91 over 103. If you haven't subscribed already, please do subscribe to JL Maths, and I'll catch you in the next video.